Hi everyone and welcome back to PrepFusion. So from today onwards, we will be starting with network theory and the AC part. So on YouTube, the DC part was already covered, but the AC part was not covered. So we will cover the complete AC analysis and the two-port networks from this lecture onwards. So I hope you have already known that we have a playlist on network theory. So you can go in that playlist and watch all the lectures. So like what we will cover AC analysis. Inside that we have phasor diagram, Lucas diagram, resonance, complex power and network theorems for AC circuits. We have learned for DC circuits, now we will learn it for AC circuits. Also we will cover the two-port networks that will come at the end. And trust me, this will be the best AC circuit, like AC videos present on YouTube or in any paid courses. Like once you will watch the first two lectures, right, you will understand from where I'm going. I will go from the absolute basics to the highest level, okay, and there will not be any doubts at all in your mind. There will be like all the concepts will be cleared with 100% clarity. So I have of course followed few books. So this is one of the books that I have followed, Charles Alexander and Sadiku. So you can follow this fundamentals of electric circuits if you want to, but if you are studying from me, no need to follow any books. I will provide you the assignment questions, I will provide you with the lecture notes, everything will be provided. You don't have to follow anything, okay, but I had to cite my sources. So this is one of my sources from where I studied network theory. So we will start with the first lecture, lecture 1A, where we will discuss about sinusoids and basics of phasors. So although I will start from the absolute basics, but if you have bit of like zero clarity, like what is a complex number, if you don't know at all what is a complex number, I will recommend there is a playlist on our YouTube channel named Mathematics Foundation. Okay, in that channel, don't have to watch the whole video. If you're really weak, don't have to watch the whole playlist. If you're really weak in mathematics, then you can watch the whole playlist. Else, just watch the complex numbers lecture. That video will be around 2.5 hours, 2.5 hours. Just watch that lecture. If you are really don't have any idea what is complex number, then you can watch. Although I will start here from basics as well, but if you're really weak in mathematics, you can go and watch that video. So this is important to clear the basics of phasor, because in phasor, right, we will operate complex, we will do complex operations, so that is important. So let's understand sinusoids and phasors. So first let's understand sinusoid. So everyone knows what is a sinusoid. Sinusoid, like every voltage signal can be written like this, any sinusoid signal, it is Vm sin omega t plus theta. So we will break down what are the each terms here. Okay, so first let's discuss about this Vm. What is this Vm? Vm is the peak amplitude and it will have a unit. It will have a unit of volts, because this is a voltage signal, it will have unit in volts. Let's say if I would have written something like this, I of t is some capital Im sine omega t plus theta, then the unit of Im will become amperes. So unit will change depending on what quantity I am representing. The unit of sine, whatever is with sine, right, this is unitless. This is unitless. I hope you know this, right? Anything if I write e raised to power minus at or something, all these are unitless. All these are unitless. This time has a unit of seconds that cancels out from this a. A will have unit of second inverse, so that the units get cancelled. Basic units and dimension. So I hope this is with full clarity. What is the first term that is written? The amplitude. This is the peak amplitude. A sinusoid can be drawn like this, okay, and this Vm represents the peak amplitude, the maximum value of the sinusoid, okay. So that is how this Vm is defined. Now let's understand omega. What is omega? Omega is the angular frequency in radian per second. Of course, the units can change. I will tell you the units for different things, but by default, the units of omega will be radian per second. By default, it will be radian per second. It can change as well. I will tell you why it will change. Don't worry about that. So by default, omega is equals to 2 pi f. And what is 2 pi? 2 pi is the radians, right? And what is the unit of f? F, right? F is what? 1 by second, correct? 1 by f, unit of f is 1 by second. So ultimately, when I multiply these two quantities, the unit becomes radian per second. Radian divided by second. That is how we get the unit of omega. Now, what is omega t? What is the unit of omega t? The unit of omega t will be same as theta, correct? The unit of omega t will be same as theta. So here we have defined our omega to be radian per second, and if I multiply omega with t, so it will be radian per second into t, so that is into second. So ultimately, right, omega t, ultimately the unit becomes radians. So unit of omega t is radians. Please keep this in mind. All these will be helpful later on, because if your basics are not clear, when I will frame a complex question, you will not be able to solve it. You will solve it wrong because your basics are not clear. Let's clear our fundamentals first, then of course we will solve the difficult questions as well. So first thing is this one, that unit of omega t is radian, that is also known as the argument. Why argument? Generally a angle is defined as argument only. Okay, this is also known as omega t, the unit is radians. And what is the unit of theta? Now it depends, right, how it is given in the question. By default the unit of theta will be radians. This is the by default unit, but it can be degrees as well. I will discuss just in the next few slides. We will discuss regarding that. What is the time period? Time period is basically 2 pi by omega. Its unit is 1 by second. I think you already know this. And frequency is 1 by 2. That I have already discussed. Also, it can be also defined as hertz. Frequency can also be sometimes written as hertz only. So let's see different sinusoids, and from there we will understand the difference, whether we need to take degrees, radians, or something else. So this is the standard notation. VIT is equals to Vm sine omega t. Here, right, if you see the x-axis is omega t. It is not time, it is omega t. And they have written omega t is in radians. So if omega t is in radians, then whatever theta I will write here, right, let's say this is some, we will come to that one as well. Let's say this is Vm sine omega t plus theta. So this theta unit also will be in radians only, because of course principle of homogeneity must lie. We are adding two products, two things here, both of them must have the same units. Okay, both of them must have the same units, then only we can only add two same components. We cannot add different types of components, correct? You cannot simply add current and voltage. You only add voltages or you add both currents, right? So here, then my theta will be called here radians. And also you can identify if it is not given here, right? Let's say in the question they have not mentioned this as radians. You can see the x-axis. If you see the x-axis, if ever it is written pi by 2 or it is written 1.57, pi by 2 is 1.57 or 3.14 or a multiple of pi by 2, that means they are telling you that the x-axis is in radians. The x-axis is in radians. That is the meaning of this. Okay, so that is the first case. We will come to the next case. Before that, I strictly want to mention your Vm will always be a positive number. Vm will always be a positive number. It is not possible to get negative Vm. If I write negative Vm, right, basically it has phase. Vm is a positive, but if I write minus Vm sine omega t, basically we can convert it. I will tell you the conversion later on, but you can convert it into something like this: sine omega t plus pi or minus pi, something like that. Don't worry if you don't know this conversion, I will tell you later on. Okay, but your Vm, right, amplitude is just a positive number. Amplitude is just a positive number. Remember this thing. Amplitude is never negative. So I will write here. That amplitude Vm is a positive number. Okay, so that is the case here. So next is the next iteration, next variation of sinusoid. This is also a sinusoid, Vm sin theta. So if you write theta, right, now your theta is in degrees. Actually here this we should have written in omega t as only, because theta, okay, if it is written Vm sin theta, if it is written Vm sin omega t, that means like by default, unless and until specified, it will be in omega t will be in radians only, unless and until specified. Generally that's the trend. If it is written omega t, by default it will be radians, the unit will be radians, unless and until specified, because omega is generally maximum cases omega is defined as radian per second only. Omega is defined as radian per second only. So if it is written omega t, that means it is in radians, maximum chances. If it is like this, sin theta, It can be radians as well, it can be degrees as well. You see the x-axis. What is written? In bracket, is it written in degree? Or here it is written 90, 180, something like that. That means it is a sinusoid with x-axis with the unit as degrees. This theta is in degrees. Okay, theta is in degrees. Now let's come to the third point. Third point is, if your sinusoid is defined something like this, sine 2 pi by t, what does it mean basically? So this 2 pi by t is what? Omega only, right? Omega was equals to 2 pi by t, or your t was equals to 2 pi by omega. Here, right, I have already told you, either t is equals to 2 pi by omega or omega equals to 2 pi by t. This you already know. I hope I don't need to explain this. So if it is written in this form and we are varying t, this is constant, we are varying t, then t, what is the unit of t? Unit of t is seconds. So unit of omega t by default will be radians. Theta can be radian or degree, depends how it is written in the x-axis here. And your 2 pi by t into t, the unit of t you already know. By default the unit of t is seconds. So here it will be written in seconds. So all these values are in seconds. So please go through it again if you are not able to understand this concept. Different sinusoids can be represented in mainly in three different manners. They can be represented in other ways as well, but mainly in three different manners. So this thing should be clear of your mind, because I have seen multiple times student has the confusion on this x-axis. They don't know whether I need to take the radian, they don't know whether I need to take the degree, or they don't know whether I need to choose the second. I hope now the confusion is totally cleared. How can you represent a sinusoid? Okay, three types we can define a sinusoid. Okay, now there is a one key property of a sinusoid that you already know. Okay, so here we have cosine and sine relationship between cos and sine, correct? This is the very standard relationship that you already know. I hope you know this. Okay, trigonometry, I hope you have studied trigonometry. So what happens with me, I tend to forget this relationship. So how do I remember this? So this is a short trick to remember this. Like I generally used to forget this. So this will be helpful in everywhere, in signals, in controls, in mathematics, anywhere this will be helpful. I will tell you. Okay, so how do you remember this thing? So one thing you remember, that your cos omega t will be coming at the x-axis. How do you remember? If you remember, there used to come, if you know about complex numbers, you complex numbers, you can define your x component as cos of theta and your y component as sine of theta. If you remember this, right, r cos theta and r sin theta, correct? R cos theta and r sin theta. So x is r cos theta. So like this you remember. So don't worry, I will clear this in Phasor, like we will come to Phasor later on, but this is a very neat trick that I want to explain. So you write the x-axis in cos omega t. Now you know sin omega t is cos omega t is sin omega t plus 90. That means if I add plus 90 to sin omega t, I will get to cos 90. Do you remember one thing, that if I am adding angle, that means I am moving in the anti-clockwise direction, and if I am subtracting angle, I am moving in the clockwise direction. This will be taught in the complex number basics. I have already taught there. If you don't know, now you know. Okay, if you don't know about this, now you know. Whenever we are adding any angle with a quantity, we will move in the anti-clockwise direction. If we are subtracting any angle, we will move in the clockwise direction. So if I now see sin omega t plus 90, so if I add 90 degree with sin omega t, then I should reach to cos omega t. So my sin omega t should be somewhere here. My sin omega t should be, this color is wrong, somewhere here. This should be my sin omega t, correct? So if this is my sin omega t, this is my sin omega t, and if I add plus 90 with sin omega t, I will reach to my cos omega t, correct? So that is how you remember. Just remember this. This will be helpful immensely everywhere. Trust me. Keep a note of this or somewhere. This will be helpful immensely. Now if I add another plus 90, if I add another plus 90, where will I reach? If I add another plus 90, basically what will happen is this will be minus sine, like basically this will be what, right? This will be sine omega t overall plus 180. And if I ever add or subtract 180 with a sinusoid or a phasor, what happens? Basically the sign changes. It will be minus of sine omega t. How? Let me prove it to you. So basically, right, we are shifting. We are adding 180, that means we are shifting. So at omega t equals to 0, what is the sine value? It is sine 180. So actually I have to choose the sine 180 value, that is here. At t equal to 0, I have to choose this value. So basically, right, I am I'm left shifting whole of this waveform on the left hand side. So if I left shift, right, I will just show you for a second. If I left shift this whole waveform by 180 degrees, you see, like just roughly if you see that previously whatever the waveform was, it is just inverted. That means just a negative sign has been added. So I am teaching you like absolute basic, like class 10 thing, okay, but I hope you know all this, right? You know all this. Still I am explaining this basic things, that if you shift 180 degrees, the sign will change. So this diagram you remember, this will be helpful because I tend to forget this relationship, but this is how you remember. Just remember that cos omega t will be here, and just write the cos first. As soon as you write cos, then you remember, okay, something comes in the downward. So I have already written cos omega t, so sin omega t will come here. From here you will figure out which angle is lagging or leading. Lagging, leading I will come to, but from here you will figure out that, okay, if I add plus 90 with sine, then I will reach cos omega t. So from this phasor diagram, you can deduce the formula that your cos omega t will be sin omega t plus 90. Sin omega t plus 90. Okay, so that is the important point that you have to note over here. That is the important point that you have to note over here. This is how you can get back. So remember this phasor, like what I told you. Remember this phasor. Phasor I will come to. Don't worry. If you don't know phasor, don't worry. Remember this thing. Just these 2 points. Write the cos omega t in the x-axis. Then you have written cos omega t. You remember, okay, something comes in the downward direction. Okay, I have written cos omega t. So of course only sin omega t is left. So I will write sin omega t. So from here you will come back to this equation. If you ever tend to forget this, if you can remember this, that's totally fine. But I used to forget this, so this is a nice trick that I used to use. Okay, there are more tricks I will like teach you as we move along this course. Another key property of sinusoids is that if I have two sinusoids of same frequency, remember they need to have same frequency. So here, right, one important point, they need to have same frequency. If I have two sinusoids with same frequency, you can use this formula. Basically, right, they are phase shifted by 90 degrees. Cos and sine are phase shifted by 90 degrees. So there is a formula as well that I will discuss how to add two vectors, that I will discuss later, but this is the shortcut. This is the derived result. So you have a cos signal here. Let's take this example. You have a cos signal here with 3 magnitude. So I have a cos signal here with 3 magnitude. If you don't know about phasors, don't worry. Don't worry, I will discuss about that as well. And you have a sine which will obviously lag here at a magnitude of 4. Okay, this is the sine magnitude. So how do you write? Like this is like a right angle triangle, correct? So this will be the resultant vector, right? I hope you remember the vector addition. This will be the resultant vector, and the resultant vector has a magnitude of a square plus b square. This is 3 square plus 4 square, and the phase from where you want to measure. If you want to measure from here, then you will choose this as your y and this as your x. If you want to measure the angle from here, then you will choose this as your y and this as your x. What do I mean? So here, right, if I write here phi, if I write here phi, what do you choose? You choose the tan inverse. Your phi will be equals to tan inverse of the altitude upon the base. What is the base in this triangle? In this triangle, the base is 4 and the height is 3. Okay, so it will be tan inverse 3 by 4 is almost around 37.13. Okay, 37.13. Not 13, I think 36.86. Sorry, 36.86. What I remember, yeah. And if you want to measure like this, let's say this is phi 1. What will be your phi 2? Phi 2, if I take any other color, phi 2, again this is a separate triangle, correct? Here what is the base? Base in this triangle is 3, right? Length of base is 3, and what is the altitude? Altitude is 4 in this case. So that's why the formula becomes different from where you like take the initial reference or the degree. So here my phi 2 will be equals to tan inverse 4 height by 3 base. So this will be 36, so not 36, this will be 53.13. Or like there is a other way around as well. This whole addition is 90 degrees. So if I subtract this angle from 90, I will get back to phi 2. That also works. Anyways works. So you get the phase angle phi. This will be the phase angle phi. So this, right, you can draw the like this vectors and do calculate the phase angle, whether it will be negative or positive. Don't need to remember the formula, just understand visually. So what will be the value of C? C will be the magnitude basically. That is very, very simple. It is Pythagoras theorem. So it will be a square plus b square under root. So it will be 5. Okay. It will be 5 basically. So C is 5, phi is 30, whichever way you want to write. If you want to write with respect to this, right, then this is your reference. And what is this? This is sine omega t. So this can be written as 5 will be constant. This can be written with respect to sine. If I write with respect to sine, my resultant is here. This is my resultant vector, C vector. In which direction I am going? Clockwise or anti-clockwise? I am moving in the anti-clockwise direction. So from sine, I have to move in the anti-clockwise direction. That means angle is getting added. So that's why there will be a plus sign here. Plus whatever the angle phi 1 we calculated, that is 36.86. 36.86. Let's say I want to write in terms of cos. So if I want to write in terms of cos, magnitude will not change. Magnitude will be same only, 5 cos. I am writing in terms of cos. This will be omega t only. And I am going in the clockwise direction, right? I have to reach to the resultant. I have to move to the clockwise direction. If I am moving in the clockwise direction, that means my angle is negative. Whenever we move in the clockwise direction, my angle becomes negative. So it will be minus of 53.13. Okay, that's about it. I hope you have understood this basic key property of a sinusoid. Now let's understand about phase shift. What do you mean by phase shift? Now many students have high number of misconceptions in this phase shift. So we will try to clear all those things. So a phase shift basically refers to displacement of two sinusoid signals in time. Basically it is the like value at which the peak comes, right? Basically how are the sinusoids present in the omega t axis. So I have three signals. One is V1 5 sine omega t, another one is V2 5 sine omega t plus 90, another one is V3 5 sine omega t minus 90. I have three signals. So if I have three signals, then what do I observe? This V1 is the normal sinusoid that we already know. What about V2? That is 5 sine omega t plus 90. This is just a cos omega t, right? And I hope you remember how you draw the cos omega t. Cos omega t starts from here and it goes on like this, right? Cos omega t is this blue signal. Okay, and this is my another. I have subtracted 90 from this initial reference, so this comes out to my V3. How can you cross verify? How can you cross verify? Omega t equal to 0, this goes to 0. So at omega t equal to 0, so I am by default generally my x axis will be omega t only by default. Okay, so omega t equal to 0, V1 is 0, fine. If I put omega t equal to 0 here, is V2 0? No. If I put omega t equal to 0, V2 is 5 sine of 90. 5 sine of 90 is basically 5. So it will be the peak, right? Because 5 is the peak value, so it will be the peak plus 5. And here if my omega t is 0, V3 is what? Sine of minus 90. And what is sine of minus 90? Sine of minus theta is minus sine theta, so it is minus 5. So if you see, your V3 is minus 5. So if you just plot the points, right, your points will come out like this. What do we observe? We observe that the peak of V2 comes before. I will just change the color. Can I change the color? Peak of V2 comes after peak of V2 comes after V1. Sorry, comes before V1. Comes before V1, right? Because if you observe, the peak of V2 is happening before V1. Correct? So, whatever I am discussing, currently I am taking V1 as reference. So, I am discussing it with respect to reference. So, in AC circuits, you have to choose a reference. If the reference is not given, you have to choose the reference by default. And how you choose the reference, that actually becomes a very big factor whether you will be able to solve the question or not. For example, if you choose a very difficult reference, right, then the question will be very lengthy and calculative. So we will discuss about that later on. So for now, V1 is reference. V1 is reference for now. What about V3? For V3, the peak of V3 comes after V1. Now we have terms for this kind of thing because this is a very well observed phenomenon in our AC circuits. So we have defined few terms for this. What are the few terms? The first term is that if something is happening earlier, that means it is leading. That means V2 is leading V1, right? V2 is leading because peak of V2 is coming first. So V2 is leading. So we define in our electrical sense, we define it as leading. So V2 leads V1 by how much? By a overall of 90 degrees, because the peak of V1 happens after 90 degrees or pi by 2 radians. So by pi by 2 or 90 degrees, anyway is fine. Okay, so I hope you understand the difference between these two things. What about this? If it is coming after, if V3 is coming after, we have a term for this, that V3 lags V1 by, here I should have written by by 90 degree or pi by 2. So it is lagging because peak is coming later on, right? V1 already the peak has came, but V3 is lagging. That is the problem. Peak is lagging. Now the thing is that many students get confused that, like, we will derive this later on, that capacitor voltage, generally the capacitor current leads the capacitor voltage, right? So they assume that I have a capacitor here. They tell me, many students tell me, I have a capacitor here and I apply a voltage, and they know that the capacitor current leads. So we say capacitor current will come first, then the voltage will come. Correct? So what they understand is that even before, like, I will give the voltage supply, automatically current will be generated in the capacitor. No, that is wrong. That is wrong. That concept is wrong. What do we mean by lead and lag? Basically, we just mean where are my zero crossing points or peak. That is what we mean by lead and lag. So basically, if I say the capacitor current leads the capacitor voltage, so I say that the peak of capacitor current will come first, then the peak of capacitor voltage will come. That's it. Both waveforms will start from same time. No question about that. Just when the peaks will come. Okay, we'll clear this later on as well. Don't worry about it. So this phase difference mainly tells us about the shift in zero crossing points, okay, or the peak values, or the when the peak happens, whether lag or lead, zero crossing points or the peak points where the peak occurs. So these are the two things that can be discussed with lead or lag. So this just means like peak means wherever maxima or minima. Minima is the lowest value -5 and maxima is the highest value +5. Maxima or minima. Okay. Maxima or minima. So these are the things that you should keep in mind for leading and lagging. So I hope you have understood. I hope few misconceptions are also cleared. okay, because lag and lead does not mean that the waveform will come fast or later. So I will write here lag slash lead does not means that one waveform will come earlier than the other. Okay, it does not mean this. It does not mean this. So just be careful, because many students have this misconception that, let's say I have applied a like a voltage, or yeah, a voltage only, and if I say the current is lagging the voltage, that means they understand, okay, so my current waveform will start from here. Before this I don't know what is happening, but current waveform will start from here. No, it is not the concept. Concept is both waveforms will start from 0 only, same point only, but just the 0 crossing points or the peak when it comes, that is different. That I have described here only. Okay, I hope now you have understood the concept of phase shift. Now in, like, although I have not discussed about phases, but basically phases are basically vectors. So for now let's understand like vectors. If I have a vector whose reference is here, okay, whose generally the reference is chosen as x-axis, that is 0 degrees. This is my reference, and if I say a reference, let's assume as v1. v1 is my reference, right? v1 has the magnitude of v1 and angle 0. I will discuss about phasor quantities as well, don't worry. The next part we will discuss about phasor representation only. But v1 is chosen as a reference, so v1 has a magnitude of v1 and angle of 0. So what about v2? What will happen to v2 then? v2 is leading. What is the angle of v2? Plus 90. I am adding omega t plus 90. So v2 will be lying somewhere around here. If I am adding something, so I will move in the anti-clockwise direction. So if I move in the anti-clockwise direction, v2 will be somewhere around here, because it is plus 90, so I am adding the angle, so it is in the anti-clockwise direction. It is in the anti-clockwise direction. Okay, so this is my v2. Angle 90. Okay, not sorry. So here, right, this is your v2. This is your v2. How can I define it in terms of v1? So you can define it in terms of v1. What I observe is the magnitude or the amplitude of both of them are same, correct? Just the phase is changing. So it has two components that I will discuss in the next slide. A phasor has two components. One is its magnitude, another one is its phase. So what do I see? That my v2 magnitude is same, so it will be v1 only magnitude, but the phase will change. Phase will be plus 90, because I am adding plus 90 with v1. So this will become plus 90. Okay, and what about v3? v3 will lag, correct, because it is minus 90. So from v1, magnitude will be same for both of them. If you see, magnitude is same, just I am subtracting 90 degrees, not adding. So I am moving in the clockwise direction. So I will move in the clockwise direction, and v3 will be this minus 90. That's it. That's how we define like a reference and phasor. So even without even teaching you phasor and all those things, still we have like understood what is a phasor. Okay, basically like slowly we are understanding a phasor. So let's see the phasor representation, how we represent a phasor. Phasor is a rotating vector. How is it a rotating vector? I will discuss in the next slide. So basically our phasor, whatever we are discussing in AC, right? Whatever we are discussing in AC, we are discussing in terms of sinusoid. Your signals must be sinusoids. It should not be some square waveform. Whatever we are discussing, these phasors, all those things are defined for sinusoids only. They are not defined for anything else. Just be careful regarding that. And this is Vm sin omega t plus theta. We use phasor notation. So Vm sin omega t plus theta can be written like this. If you assume, if reference of sine, what is the reference here? Can you tell me what is the reference? Reference is simply sine omega t. A sinusoid whose amplitude is 1 and whose phase angle is what? Whose phase angle is 0, because additional, I am not giving it any additional phase shift, just omega t is there. So if this is my reference we write like this in the x-axis. This is my reference is sine omega t. Generally this, right, is implied. You will not write this, that reference is equal to sine omega t. It is understood that yes, you are choosing a reference as sine omega t only. It is internally understood. So how can I define this sinusoid then? What you do, you write the peak amplitude here and the phase angle here. Okay. Now many students will have doubt, who will know about this, whether I need to write this RMS or peak. Whether I need to write this RMS or peak. If you know about RMS and peak, if you don't know, ignore this particular portion. For those students, what I will say is you can write both in RMS and peak. Both RMS and peak. Whatever is suitable. Whatever is suitable for you. Whatever is suitable. This is a freedom to you. This is a freedom to you that you can choose whatever you like. Now, the important portion is, if they want to take away the freedom, they can. They will take away the freedom by telling you that they have chosen this magnitude part to be the RMS. It will be mentioned in the question. Magnitude part is RMS, that will be mentioned in the question. And let's say if they don't mention. If they don't mention, by default, you will choose RMS. Very, very important statement. Like multiple times I have seen this confusion. If nothing is mentioned about the phasor, about the magnitude of the phasor is just a complex number, right? It is just like a complex number. Complex number has a magnitude and a phase. So if nothing is mentioned, by default, you will choose RMS. Okay, by default, if you will choose RMS if nothing is mentioned. That is the most important part. Okay. But here, right, we can choose. If freedom is given, we can choose according to our convenience. So sometimes I will choose the amplitude, peak value. Sometimes I'll choose the RMS. So you have to be smart enough to understand, okay, sir has chosen here amplitude. So whatever, if once I have chosen amplitude, right, whatever I will write proceeding to that should be with amplitude only in that question. For that particular question, if I have chosen the amplitude, then all the quantities will be amplitude only. Magnitude will be amplitude only. If I move on to some other question, there I can choose RMS. So with different question, I can change my approach. But for a particular question, if you have started choosing the peak, you will finish with the peak only. Because let's say I have written this Vm theta. How do I go back? So I understand the information. Whenever you convert this, right? Whenever you convert this sinusoid to phasor, which information gets lost? The information about the frequency term omega gets lost. So I will write information about omega gets lost. So how do I get back that information? How do I get back that information? Simply, it is understood that this circuit is operating on a single frequency only, single tone signal only. So when I will come back to this, right, I know this will be my peak value and this will be my phase shift, and I will replace my frequency with omega, because that is internally understood by you that the frequency will be omega t only. Okay. So if I am writing, while converting from sinusoid to phasor, if I am writing my phasor like this, that means I am choosing my magnitude to be the amplitude of the sinusoid and theta to be the phase angle. When I will come back, this value will be the amplitude of my sinusoid and this value will be my angle. Okay, so just be careful regarding this thing. For different questions, I may choose different references. Okay, so let's say I have example, like this is the example, right? This Vm sin omega t is there. So I have chosen this as like once sin omega t is reference. So this component, this sinusoid will be represented as Vm angle of 0. That is, the peak value is same, but the phase shift is 0 because I have chosen a sinusoid as reference. So here internally you have understood that your sin omega t is reference. Here Vm cos omega t. How can I write in terms of phasor? I have written Vm plus 90. Vm basically means the peak value of that particular sinusoid, and plus 90 basically means the addition of sinusoid. That's it. Okay, plus 90 basically means, no, sorry, plus 90 basically means I have to add 90 degrees to get to cos omega t. I have taught this in the starting of this lecture. So that is what we're doing. That is what we are doing. So this, right, can be written like this, that is, it is Vm sine omega t plus 90. So from here the theta comes. Now let's say you want to write in RMS. If you know about RMS, very well and good. If you don't know, you can ignore this portion. So for RMS, if I want to represent, this will be Vm by root 2, correct? Because RMS of a sinusoid is peak by root 2. So the phasor for the first one will be Vm by root 2. Phasor for the second one will be Vm by root 2 90. Angle will not change obviously, but the magnitude will change. So here it is internally understood by you that here you have written the RMS. So when you will come back to your sinusoid, what type of conversion you will do? First you will multiply under root 2 with the magnitude, and then you will add the phase angle with the sinusoid. That's it. So for this RMS thing, you have to follow a extra step. That's it. Okay, but if nothing is set, by default you will choose RMS only. So let's understand the fact that is phasor really a rotating vector. Now this is just like a, what do you say, a term like a thing. Okay, there is no physical significance. So basically what we do, right, this is the sinusoid, right? So I assume I have a phasor with constant magnitude and the angle varies with respect to this sinusoid, right? So at omega t equal to 0, angle is 0 only. After a certain point, angle increases, angle becomes positive, so I am moving in the clockwise direction. So initially I was somewhere around here, then I moved in the clockwise direction here, here, and it will keep on moving like this. So what will happen, I will keep on moving in the anti-clockwise direction because angle is only increasing. Okay, so what we do, like, there is no physical significance because many teachers say this point, you will say, sir, you have not taught this point. Basically, right, it is like a circle. I will draw the circle and then I will show you. It is just like a circle. So what happens, initially my angle was 0, then it increased to some positive angle, then again I came here, then my angle become pi by 2, so that's why it is plus 90. Then again my angle become here, that is somewhat more than pi by 2, then I am here. So one more thing, sometimes I will take pi by 2, sometimes I will say 90. Pi by 2 means radian, 90 means degree. So that you have to understand internally that what I am saying. I am saying degree or pi by 2. That is understood, right? So again this will be somewhere like, this is 180, right? This will be somewhat more than 180, like 200. Again I will come here, that is 270. This will be more than 270, like 300. And ultimately if I rotate a full circle, what is the angle? It is 360 degree. So with angles, if you add or subtract 360, you reach back the same place. So theta plus minus even or integer multiplication of 360 is basically the same angle only, theta only. Okay, it does not change. 360, or what can you write? In radians it is 2 pi. In radians it is 2 pi. So that was about the phasor, like this rotating vector concept. This is about the rotating vector concept. Now what more can we understand? One more thing is here, that the phasor relationship. So in phasor, right, you plot complex numbers. So if you have a phasor quantity, let's say V angle 30 degree, or let's say 2 angle 30 degree, that basically means it is a complex number. I will tell you how to represent complex numbers as well. I hope you know this is the polar form of complex numbers, right? Polar form of complex number, and you know polar complex numbers have a real part and imaginary part. So same for phasor as well. So this phasor, it will have a real component and imaginary component. What is the real component? Real component is 2 cos 30. 2 cos 30. And what is the imaginary component? Imaginary component is 2 sin 30. I hope you know how to convert from real to imaginary. In the next few slides, it will also come basically. So what will the component here? The real component will be 2 sin 30. 2 sin 30 will be somewhere, sin 30 will be lower, it will be somewhere here, real component, and imaginary component will be somewhat higher, 2 cos 30. And the resultant, it is just like a vector addition. Resultant of these two components will actually yield me the phasor, right? So this is the 2 angle 30 degree phasor represented in the imaginary and real axis. So generally we assume the real axis to be the reference and with respect to that is we tell that the leading angle is like it is going in the anti-clockwise direction with 30 degrees. Okay, and if I go in this direction, if I ever go in this direction is known as the leading direction, because I am adding the angle and leading means addition anti-clockwise. So whenever I move in the anti-clockwise direction in phasor, that means I am going in the leading direction, and whenever I go in the clockwise direction in a phasor, that will be the lagging direction. So let's say initially I had a phasor whose angle was 0. So this angle was 2 angle 0. Okay, and I added, like amplitude is same, but I added a 30 degrees angle. So what happens, I went into the leading direction, in the anti-clockwise direction. So that's why my phasor became 2 angle 30. Now if I want to represent the same in lagging direction, that means I have subtracted 30 degrees from my initial phase. I have subtracted 30 degrees from my initial phase, so it is in the lagging direction. So what will be the phasor representation? It will be 2 minus angle minus 30. That's it. It will be 2 angle minus 30. So, and each quantity, remember the information about the frequency is gone, right? So we assume that this quantity has a frequency of omega. Okay, so assumption is this is a polar representation. This is, if you have studied complex number, in complex numbers this is just a point, but in phasor this is not a point. This is a sinusoid. Sinusoid whose frequency we know, that information is lost, but amplitude is given here. Either it will be RMS or peak, and angle will be plus 30, the phase shift. Okay, so in complex number it is just a point. Students who have studied complex number, they will understand this. In complex number it is just a point, but in sinusoid, sorry, in our phasor or in AC analysis, the whole network theory lectures, it is a sinusoid. So there is a very huge difference between these two quantities. That's why we say it is a phasor quantity. We could have said it is a complex number. No, we say it is a phasor quantity. Although the representation is almost ditto same like complex numbers, but complex number there we used to say it is just a point in the complex plane. But in this case it is not just a point in the complex plane, it is a sinusoid. Okay, so I hope you have understood the difference. Now with whatever knowledge we have learned, try to solve this question. Like all these will be assignment homework questions to you. I will solve this in the next lecture in the assignment solutions. Okay, in this lecture I will not solve very basic question. All the basic things I have already explained, so I hope you will be able to solve this question. Now let's read few key points. First key point is phasor diagram visually represents the phase relationship between sinusoidal voltages, currents in a AC circuit. So that is why we had to have a good representation, because every time writing sine cos is very tedious, and doing computations with sine cos is very tedious. We'll see what are the operations that we can do in phasor quantities. So that's why we had to make a separate format, that is the phasor diagram and quantity. Phasor diagram is also very helpful. You will be able to easily solve AC questions with phasor diagram. So phasor diagrams are primarily used for analyzing complex AC networks like AC elements with reactive elements. What are the reactive elements? The inductive and capacitors. Resistors, why are they called reactive elements? Because this L and C are function, not L and C, sorry, the reactance that they will provide. What is reactance also, that we will come to, don't worry about that. But for now just understand this, the reactance that this L and C will provide are function of omega, L and C. So XL and XC, XL is the inductive reactance, XC is the capacitive reactance. So both of these, whatever reactance they will provide, are both functions of omega. And they, like, what are the application of phasor diagram? They simplify calculations for AC circuit analysis by converting differential equation into algebraic ones. So at the end of this lecture there is a one question where you will see, if you convert the differential equations into that Laplace domain or the phasor domain, it will be easier. Okay, so that also we will see. So basically your calculation gets simplified. The limitation, like there is no limitation as such, but there is no concept of phasor representation for purely resistive network, because in such cases voltage and current remain in phase. So that's where the phase name came from. Where does the name phase came from? Phase name came because the voltage and currents were not in both phase, were not in same phase. They had a phase shift between them, that I will derive in the next lecture. In the next lecture we'll learn about that they have a phase shift between them. Okay, so due to that we had to show a new representation, that is the phasor representation. Okay, so in resistance, right, there is no concept of phasor. Why? Because if I know the voltage across a resistor, let's say VR of t is Vm sine omega t, then the current will be what? Current will be just a scalar multiplication divided by the resistor, right? So basically it will be Vm by R sine omega t. There is no phase shift. But in case of inductor and capacitor, there will be phase shift. Basically, the sine omega t will not stay sine omega t. It will be sine omega t plus 90 or minus 90. So there will be phase shift. To represent that, we had to use phasor representation. So for resistors, there is no concept generally for just for purely resistive network. There is no concept for phasors. For other type of components like L and C, there is concept of like phasor. So phasor form, I have already discussed. Phasor can be written in separate many formats. So just how we can define a complex number, or the number of forms for a complex number is there, same is for phasor. Just the difference is this point z is not a point anymore, it is representing a sinusoid. That is the only difference, except it is ditto same for phasor. Okay, complex number representation and phasor representation is ditto same, just what do they mean, what is the physical significance changes, that's it. So basically from rectangular form, if you ever want to go to polar form, or polar form, if you ever want to go to rectangular form, so you know this formula, that this r will be here only, it will be r sine theta, so not sine theta, r cos theta, the real component, plus j sine theta. This much you know, right? I hope I don't have to explain this part. So you can come back to this format. This will be the rectangular format and this will be the polar format. So if you want to go back to polar format, if you have rectangular format, what you will do, your r will be x square plus y square whole under root, the magnitude, and phase will be tan inverse y by x. Now this angle, right, how to calculate the angle, that also I will discuss in the next slide, because there is a huge confusion on this angle. All the confusion of angle will be cleared in this lecture, trust me. Okay, because I know students suffer in this angle concept only. Magnitude is easy, right? Magnitude is easy. It is a positive number. It will be under root x square plus y square. That is very easy. But to find out the angle, you have hundreds of confusion, and today all those confusions will be cleared. Okay, so okay, just hold on. My screen got closed. Yeah, we are here. So I hope it is recording. Yes. So if I have, let's say, any sinusoid voltage. Okay, I have a circuit here. Any random circuit I have, RLC. This is what we will discuss for the next 20 days, 22, 25 days. So if I have a here R, L and C, and it's a sinusoid. Remember, all whatever we are discussing, the input has to be sinusoid, else everything goes down the drain. Input must be a sinusoid, then everything then all the discussion is valid. So this is my current V of t, and this is my current this is my voltage V of t, and this is my current I of t, and it is R, L and C. Okay, so what I can say is, I have a voltage here VL of t, I have a voltage here VR of t, and I have a voltage here VC of t. I of t is same for both of them. So my V of t will be some Vm sine omega t. Okay. Now what will be a current? So what will be the VR of t? So VR of t can have some phase. I don't know what is the phase, and its amplitude also can change, because there is some voltage division happening, right? It will not be Vm. It can be Vm, which we will learn in resonance. It can be Vm as well, but it can be something else as well. Amplitude can be something else, because there is some voltage division happening. So it will be Vm R sine omega t. Now there can be a phase, there cannot be a phase. Like which will, I told you, right, there is no concept of phasor in resistive networks. Then your doubt will be, sir, this two things will be in the same phase. No, These two things will not be in the same phase. What will be in the same phase, I will explain. So if its voltage has some angle, let's say theta r, then for a resistor, both the current through the resistor and the voltage must be in the same phase. Through the resistor, remember the point, through the resistor. So if this is the voltage across the resistor, then the current IR of t will be equals to some IMR, I don't know what it will be the amplitude will be some random value into sine omega t, of course it has to be in the same frequency, plus theta r. They must not have any phase shift. The voltage across the resistor and the voltage across the current across the resistor must have same phase shift. Their phase shift should be 0. Okay, yes, the supply voltage and the current across the resistor phase shift can be there. The voltage across the resistor, the voltage across the supply phase shift can be there, but the voltage across the resistor and the current across the resistor, both of them must have the same phase shift, that is 0. Okay, with respect to either with respect to reference, they must have the same phase shift, or they have between them they have 0 phase shift. Okay, very important point. Okay, because many students get confused here only. What about the actual current of the circuit? So actual current, right, this is a series circuit, so whatever the current through the resistor will be the actual current I of t will be same only. Okay, what about now, how can I write this in terms of phasor? So if I assume this one, if I assume my reference to be sine omega t, so my reference, I will write here reference is just amplitude 1 sine omega t. This can be written like this, 1 angle of 0. Then how can I write it? So here there is no phase shift with respect to the reference, but the amplitude is getting multiplied by Vm. So I will write here Vm angle 0. What about here? Here the amplitude is getting multiplied by Vmr and phase shift of theta r is there. So this will be written like this. This will be Vmr and theta r. This one with respect to the reference, amplitude is getting multiplied by Imr and theta r is again there. So it will be Imr in phasor. This is what I am representing in phasor, theta r. Okay, so this is how you represent voltages and current. Now let's understand the same for inductor and the capacitor as well. So I'll just copy this, paste this over here. So if I want to understand the same for inductors and capacitors as well, so I have this voltage across the inductor, right? So voltage across the inductor will have some different phase than the initial supply. So that we will derive in the next lecture. So let's say its amplitude is something VML sine omega t plus alpha. This can be a possibility. So it is alpha. So basically, how will you represent this in phasor? It will be VML angle of alpha. Okay, because the phasor reference was with respect to 1 sine omega t. This is the amplitude and this is alpha. Now, if you want, all of this can be written with divide by root 2, because you will say, sir, you said that by default we choose RMS, so you should have given here root 2 for the students who know that the RMS of a sinusoid is 1 by root 2 times its amplitude. Yes, you are correct, but it's my basically my freedom, right? मेरी मर्जी है, मैं कुछ भी ले सकता हूँ, ठीक है? तो I will choose this. Here it is convenient for me to write the peak directly, copy the peak here. That is why I am choosing. So it is your freedom, but remember, it is your freedom to choose how you represent the phasor. But once you come back, right, come back from the phasor to the sinusoid, remember what was your, how you represented. If you written here the peak or the RMS, whatever process you followed here, same process should be followed while coming back. That is what you have to be careful. That's it. Okay. So you can represent, let's say the capacitor voltage, it is some VMC sine omega t plus beta. It will be equals to VMC of beta. That's it. Okay, so very basic thing, how to write different phases with different sinusoid, that much I have explained. So now let's come to the most important topic of today's lecture, and please listen to me very carefully here, because most of the confusion starts from here only, the phase angle. How to choose the phase angle? Sir, how to choose the phase angle? Because I have a point x comma y represented, I have a complex point x plus iy. Okay, what if I want to convert back to the polar format or the exponential form? What will be the phase angle here? Because sometimes the phase angle is negative, sometimes it is positive, sometimes it is 180 minus some value, sometimes it is 180 plus some value. All that will be cleared here. So let's say you have a complex number or a phasor number, okay, like this, z equals to x plus iy. How do you find out the angle? So if your x and y are positive, that means it is lying on the first quadrant, correct? Your point is lying on the first quadrant. So always remember the theta or the angle is measured with respect to the positive x axis. It is always measured with respect to the positive x axis. That's it. Okay. So if I am lying in this quadrant, can you tell me, let's say I have an example point here, somewhere here. Okay, this is my point, correct? So what will be the angle? Will it be positive or will it be negative? I am moving in the anti-clockwise direction. If I am moving in the anti-clockwise direction, it will be something positive. Okay, for now let's assume it is positive, correct? So here your phi will be positive and your phi will be simply equals to theta. What is theta? Theta is simply this value. I will come to this, don't worry, I will come to this. Let's check same for the second quadrant. In the second quadrant, my x is negative because I am lying on the negative side of the real axis and the y is still positive. If that's the case, then what happens is basically, if you form, right, if you get to this point, let's say my point is lying here and your x value is this one, right? Your x value is this one. Just talking about the length. Actually x is negative, right? Actually x is a negative value. That's why I am lying in the negative side. But here I am just talking about the magnitude, the length of the side, and your length of the y. This is a triangle, right? This is a right angle triangle. Length of the y is this, right? Correct. So what you do, ultimately what you have to find out? You have to find out this value, correct? You have to find out this angle. You apply a trick. So you got a right angle triangle. So you try to find out this angle and this whole is 180, right? So what you do, you write 180 minus the identified angle of the triangle. So this theta is basically the angle of the triangle, that's it. This theta is the angle of the triangle. That's why there is always positive. If it is always positive, you will never have any doubts because this theta will always come out to be some positive number. This theta will come out to be some positive number because this is just for calculating the angle of triangle. That is that, right? Ultimately you will not show you in your solution. That is for our purpose, our understanding. So here you find out this theta and from here you subtract 180 minus theta because this whole angle is 180. So you subtract the excess angle and you get back this angle. What about the third quadrant? Same concept, just bit of difference is that in third quadrant both your x and y will be negative. If both my x and y are negative, I am lying somewhere around here. Again the triangle will be same only, but this time, right, the angle, this is my triangle, correct? This is my triangle. Again this is my x and this is my y. So angle is here, correct? Angle is here. So two things you can do. Two things you can do. This is theta. One thing is either this whole angle is 180 and if I add another theta I will reach to this point, or what you can do, you go subtract minus 180 because if I am moving in the clockwise direction I will subtract minus 180 and from the minus 180 I will add the extra theta because I have to move again in the clockwise direction. That's why I will add angle. First I subtracted minus 180 because I had to move in the anti-clockwise direction, sorry, because I had to move in the clockwise direction, that's why I subtracted 180. Now I have to reach to this point and this point is clockwise direction theta. So that's why I will do minus 180 plus theta. So both things you can do, either you do plus 180 plus theta or you do minus 180 plus theta. Both are same. How? I will prove it to you as well. So either you do plus 180 going in the anti-clockwise direction, whatever we have been doing till now, plus theta. Now I previously I've told you adding and subtracting 360 does not make any difference. Correct? I've told you, right? And you also know adding and subtracting 360 does not make any difference to the angle, because you rotate a whole circle and you come back to the same place. So if I subtract 360, still it should be the same point. What am I getting? It is minus 180 plus theta. Isn't that I told you in the second case? That is, if I subtract 180, that means I'm going 180 degrees in the clockwise direction, then I move theta in the anti-clockwise direction. So ultimately my value becomes minus 180 plus theta. So either way works. I don't want to confuse you. Whichever one suits you, you just understand. I am just explaining you this graph because I know most of the students have doubt in this graph. How will you solve complex quantities if you don't know how to calculate the angle? What about the fourth one? Fourth one is the easier one. Basically, again there is an imaginary triangle, and this is my base and this is my height, correct? So the imaginary triangle, the angle is going in the clockwise direction from positive x-axis. Again, as I am moving in the clockwise direction, basically my angle phi will simply be equals to minus of theta, because this angle is positive only. This is a triangle, this angle will be positive. As I am moving in the clockwise direction, that's why this will be in the negative, minus theta. Theta is positive always because I am doing mod. Theta is always positive. Okay, so here the actual phase angle phi will be 180 minus theta. Here the actual phase angle phi will be theta only. Here the angle phi will be 180 plus theta or minus 180 plus theta, or in the fourth quadrant the phi will be minus theta. Now do you have to remember this? No, right? This, right, is a concept. This is a concept. So this should be inbuilt, and I have derived, I have explained how each angle comes. So even if you forget, just on the paper, pen and paper, rough paper, you just draw the graph and derive. Okay, so you should not you shouldn't mug this up. You should not mug this up. Why is this happening? You should understand the concept behind it. Okay, so I hope you understand the concept. Why are these numbers making sense? So this is an example, and through this example it will be cleared more. So let's represent the following complex number in different Phasor form, that is basically in the polar form. It is given in the rectangular format, we have to convert this in the polar format. So if I write this point in the complex plane, it is plus 3 plus 4, the first one. So it will be somewhere in the x, it will be 3 distance, in the y it will be 4 distance. Okay, in the y it will be 4 distance, in the x it will be 3 distance. So basically here now what is angle? Process 1, always if it is given in rectangular format, first thing that you do, like this is just for explanation that I am drawing here, obviously you know, right, in which quadrant it is lying, but first time we are doing it, so I am explaining it. But next time your first instinct should be, first you calculate the theta. First process is calculating theta. Theta is very simple, just take the positive values, tan inverse y upon x. So the imaginary part upon the real part, the magnitude, the absolute value. So it will be tan inverse y upon x, tan inverse mod of 4 divided by mod of 3. So it will be equals to tan inverse 4 upon 3. What is the value? Tan inverse 4 upon 3. You should remember these values because this will be helpful in most of the places. 53.13. I will tell you also which angles you need to remember. I will tell you. Okay, 53. This comes out to 53.13. Just the angle, as it is in the first quadrant, so my angle, right, so basically to convert this into polar, it will be r phi or r e raised to power j phi, something like this, correct? So phi will be equals to what? Phi will be equals to theta. Why? Because it is in the first quadrant. My point is in the first quadrant, that's why phi will be equals to theta. So it will be 53.13. Again you can write in radians. Always you can write in radians. You are always welcome to write in radians. Okay, convenient for me because I remember the degree, I don't remember the radians, so I will write in degrees. Okay, you can write both in radians or degree. So what is the magnitude? Magnitude is pretty simple, right? It is just x square plus y square under root. So under root 3 square plus 4 square is 25 under root, that is 5 only. That is 5 only. Okay, so z is equals to under root 25, that is 5. 5 angle of 0.13. That's it. 53.13. Now let's, like, this was easy. This was easy. Let's come to the other parts. Now this one. Where is this lying? This is lying in the second quadrant because my x here is negative. If my x is negative, so I will be lying somewhere around here, correct? So here what will be the angle? First thing is I will calculate the theta. Theta will be again same only, tan inverse mod of y upon mod of x. So mod of y will be mod of 4 upon mod of x will be mod of minus 3. This will be 53.13. Okay, 53.13. Now next is the phi. What will be the phi value? Phi value, as it is lying in the second quadrant, and I have told you this is the whole angle 180 plus 180, and this is the extra angle that I moved in the anti-clockwise direction. So I have to subtract this extra angle. So I have to move theta in the clockwise direction. So it will be 180 minus theta. So phi will be 180 minus theta. So this value comes out to be 180 minus 53.13. 53.13. So 180 minus 53.13, this will be what? This will be equals to what? This value 180 minus 53.13, this value will be equals to 126.87 degrees. Okay, this will be the angle value. This will be the angle value. Got it? So here phi will be 126.87. So here magnitude will be same. Magnitude will not change. So z will be equals to 5 angle of plus 126.87 degrees. What about this one? So this, right? Okay, I have copied the same one only. This will be negative one. I forgot to copy the same negative one. Okay, I will copy this one. Copy. I think last one also we copied. That's something else. Yeah. Okay. This should be okay. Now this is fine only. This one is fine only. Yeah. So here both are negative. If both are negative, that means I am lying in the third quadrant. My point is somewhere here, right? X and y both are negative. So first thing, again the same procedure that we already have calculated. The theta. Theta here will be tan inverse. Theta will never come different. Will be mod of y, that is mod of minus 4 divided by mod of 3. Okay, this will be equals to 53.13 degrees. 53.13 degrees, and 2, your magnitude will be, z will be equals to under root x square plus y square. So it is 3 square plus, basically, like not this, sorry, first phi, right? So what will be the phi in this case? Again, your imaginary triangle is here. This is my theta. So again I have either moved 180 degrees in the anti-clockwise direction, another theta I have to move in the anti-clockwise direction to reach this point. It will be either 180 plus theta, or same thing, if I move 180 in the clockwise direction and then move theta in the anti-clockwise direction, I will reach the same place, same as minus 180 plus theta. Both are same, both does not make any difference. So either, if you, like I told you, right, one thing previously, either if you add or subtract minus 180, it does not matter, sign will change. Basically, what do I mean by it? Either if I'm at this point, let's say if I'm at this point, if I add 180, I will reach here. If I subtract 180, I will reach the same point only, correct? So it does not matter. So if you have something like this minus 1, this can be represented one angle of 180 or one angle of minus 180, does not matter, both are same thing. Okay, so this will be, theta is 53.13, so 180 plus 53.13, this will be 233.13 degrees. Okay, 233.13 degrees. Okay, so that is the thing that you have to understand over here. Yeah, so here 5 will be this, again magnitude is same only, magnitude of z is same, 5 only. So your phasor will be 5 angle of 233.13 degrees. Last one Last one, right, is pretty simple. Again, I can leave it up to you, but I will do it. So last one, both are like one is negative, y is negative, x is positive. So I am lying in this quadrant. Again, for this it is fairly straightforward. Again, theta will be 53.13 and your phi will be minus of theta because I am moving in the clockwise direction, minus 53.13, and ultimately your phasor. I am doing this quickly because like this will bore the other people. So if you don't know, like try to solve it by yourself. So it will be magnitude of 5 angle minus 53.13. That's it. Pretty straightforward. And now I hope all the confusion regarding the angles have been cleared. Now let's see few identities that I want you to remember, because that will be helpful everywhere, not just for network theory. It will be helpful in all the subjects, all subjects. Okay, trust me, when I'm saying something, I'm saying it like with more research, right? I have done the research. So all these identities, this I hope you study in your school. So if you, even if you have forgotten, so I have written, summarize all the identities that you need to remember, like tan inverse 1, tan inverse 2, what is the value, tan inverse root 3 by 2. Root 3 by 2 you can actually ignore. Okay, root 3 by 2 you can ignore. Tan inverse root 3 by 2 you can ignore for now. Okay, something is wrong. Tan inverse 1 by root 3 is wrong, right? It should not be this. Tan inverse 1 by root 3 is wrong. Tan inverse 1 by root 3 is something like this 30. Okay, this is wrong. Okay, sorry. So this is, I think, tan inverse 1 by 3. Yeah, this is tan inverse 1 by 3. Sorry. This will be right. Tan inverse 1 by 3. Tan inverse root 3, I think you already know, so I don't need to specify that. Tan inverse root 3 you already know. Okay, this is tan inverse 1 by 3. And what about this one? I don't think this will be tan inverse root 3 by 2. This will be 3 by 2. Huh? No, this is root 3 by 2 only. Root 3 divided by 2. No, this is wrong. So what is 36.8610? It's something 3 by, oh, it is 3 by 4. Okay. This is wrong again. This will be 3 by 4. Sorry for the changes. This will be 3 by 4. Okay, so I'm sorry. So like these basic identities, I hope you can remember, like, you know, even if there is some mistake, I think you will be able to identify it. Okay, so I'll just quickly verify. If there is mistake, you guys will shout at me. So currently I'm not seeing any mistakes here. Tan inverse, yeah. So you can remember this, or you can ignore. At least these you remember, right? These you remember, but totally rest assured, it is obviously present in the gate calculator. You will be able to calculate with gate calculator. But if you want to save time, if you want more speed, more efficiency, right? So in those cases, if you remember these values, right, it will be helpful, because these values will come. Again, tan inverse, tan 45 plus tan 45 is 2, tan 53 I have already told, it is 4 by 3, and tan 36 is 3 by 4. So ultimately these values, right, same values only. Okay, and this identity also you should remember, tan inverse x plus tan inverse 1 by x is pi by 2 for x greater than 0. Obviously x has to be positive, and this I have already told you previously. Okay, so these things you remember. Obviously you remember the tan inverse root 3, all those things. Assumption is all those things you remember already, right? So those things you know. Now let's come to the arithmetic operators of phasors. So with phasors, or basically complex numbers, we can do addition. There is no problem. We can do addition, we can do subtraction, we can do multiplication, we can do division. Okay, so this we can do, but this is just with the complex number, not with sinusoids. This is not with sinusoids. Remember, this is just with the phasors. Okay, just with phasors. I am talking about just phasors. We will discuss. There is a separate topic, the operations with sinusoids. Which operations you can perform, that I will explain. Okay, so with phasors you can perform everything. Addition is, you already know. You can simply convert it into the rectangular format and you can add. You can perform subtraction, z1 minus z2, so it will be x1 minus x2 plus y1 minus y2. You can perform multiplication, z1 z2 will be equals to r1 r2 theta 1 plus theta 2. So whenever you are doing multiplication or division, try to use the polar form or the exponential form. That will be helpful. That I hope you already know this. And if you are doing addition or subtraction, try to use the rectangular form. It will be easier that way. And of course, I hope you remember the complex conjugate. Complex conjugate is just the negation of the imaginary part. So there are few properties that I wanted to say. Is multiplication, whenever I multiply two numbers, their magnitudes in the polar format gets multiplied and their angle simply gets added. So let's take a simple example. Let's say I want to multiply this number z theta with itself z theta. What will happen? What is the magnitude? Magnitude is the z and angle is theta. So magnitudes will get multiplied. So this will be z square and angle will be what? Sorry, I can write, okay, it would be better if I represent my z to be r theta. Okay, z is r theta. Now if I'm multiplying z square, right? If I'm multiplying z with itself, I can write z square. Basically, z square will be equals to z into z. I'm multiplying z with itself. Z dot z equals to r theta. So simply the magnitudes will get multiplied, r square, and the theta will get added to theta. Simply the magnitudes will get multiplied and the thetas will get added to theta. That's it. Okay, and so ultimately what is happening? This is just a formula. If I have z raised to power n, like no need to remember this, just need to understand the concept. Then basically their magnitudes will be r raised to power n and their angles will be added. That's why it will be n theta. Okay, you can replicate the same. Now let's say if I have something like this, if I have z raised to power 1 by n, that is like a square root, under root kind of thing, right? Z raised to power 1 by n, powers will change, right? It will be simply r raised to power 1 by n, and here instead of theta it will be theta by n. That's it. So these things you should keep in mind if you are performing some operations. What about square root? So square root is a very, very important number. So for finding out square root, generally better thing would be you convert that into polar format, r theta, and then you take the square root. If I take the square root, what will happen? Simply this half will come with the magnitude, with angle it will be divided. That's it. Angle it will be divided. So this will be r raised to power 1 by 2, angle it will be phi or theta by 2. That's it. That's how you find the square root, simply using this formula. One more interesting fact there is that plus j. How can you represent plus j? So plus j, right, is purely imaginary. If plus j is purely imaginary, basically you represent it like 1 angle 90, right? Why? Because my 1 is in the positive real axis and plus j is somewhere here in the imaginary axis, correct? So I am moving in the anti-clockwise direction. How much angle? 90 degrees. So that's why plus j will be represented 1, because magnitude is still 1 and angle is plus 90. How is 1 represented? 1 is simply represented 1 angle 0 because it is lying on the real axis, positive real axis. How is minus 1 represented? So minus 1 is somewhere here, correct? So how much do I have to move? Either 180 degrees in the anti-clockwise direction or 180 degrees in the clockwise direction. Any one works. So basically it will be represented like this. Magnitude is 1, but it is either minus 180 or it is magnitude is 1, it is plus 180. Okay, either minus 180 or plus 180, that's it. So that is the thing over here. I hope you have understood this point. Now let's discuss this thing, that what about this number 1 by j? So for 1 by j, right, like if you remember, you write directly minus j, but how does it come? Basically how does it come is you multiply and divide by j on both sides, numerator and denominator. So it is j into j, and you know j square is minus 1. I hope you know this, right? This much you know. So j square is minus 1. This is j divided by minus 1, or this is minus j only. So we write this directly, but if you want to know how this came, this is how it came. Okay, so it is minus j. So how do you represent? Minus j will be somewhere here, correct? So either I am moving plus 270 degrees in the anti-clockwise direction. So minus j can be represented, magnitude is still 1, either plus 270 degrees, or I can directly say 1 minus 90. I am moving 90 degrees in the clockwise direction. Generally we do this. Generally we represent this one for our own convenience. Like nothing fixed. Both are absolutely correct. Okay. So I hope you have understood. Now few more doubts few students may have is that, let's say if I have a negative number. Okay, negative number, what do I mean by negative number? Is something like this. Just hold on. So my R1, my R1 is R1 angle of theta 1, my R2 angle of theta 2. Okay, just hold on a second, I will drink a bit of water. So let's assume that this is negative, okay, it is minus. So now how will you multiply? So better thing would be you first convert it in standard format. You write here magnitude of R2 and theta 2 either plus minus 180, both of them are saying the same thing only. You write this in standard format, then you multiply. Okay, that will be my recommendation. So what you will do, you will multiply R1 R2. So your R1 R2 will simply be equals to R1 magnitude of R1 into magnitude of R2 theta 1 plus theta 2, and of course don't forget this extra angle plus minus 180. Okay, plus minus 180 degrees. Okay, so both will work, either positive or negative, both are working. Okay, and let's say if you have division, if you are dividing R1 by R2, then what will happen? Then what you will write, this will be magnitude of R1 divided by magnitude of R2, and angles will be subtracted. In division, angles get subtracted instead of getting added. So this will be theta 1 minus theta 2, and this will be minus plus of 180. So if you have chosen here plus 180, then you will choose here minus. If you have chosen here minus 180, then you will choose plus. The angle sign will be changed. Why? Because in division subtraction happens, correct? So that's why angle sign will be reverse. That is the reason why I have written here minus plus specifically. Okay, I hope you have understood this point. Very simple and straightforward to understand. So now let's come addition of two phasors which have any random angle. It is just like a vector addition, just like a vector addition. So angle, I will not be able to comment what is the angle. For angle, right, it is better to convert in rectangular. So I will write here for angle, convert to rectangular, and whatever method I have told you, you can use that method to find out the angle. So for angle, convert to rectangular format. Now if you want to just find out the magnitude, so there is a shortcut. Basically it is a vector addition, right? And I hope you know how to do vector addition. So in vector addition there is a formula of the parallelogram law. What does the parallelogram law say? That my x resultant will be equals to under root magnitude of x1 whole square plus magnitude of x2 whole square plus 2 cos of what, plus 2 into magnitude of x1 into magnitude of x2 into cos of theta 1 minus theta 2 or theta 2 minus theta 1. It does not matter because cos of minus theta is plus cos theta. So it does not matter, just the difference of the angle, that's it. Just you have to take the difference of the angle, that's it. Does not matter if it is cos theta 2 minus theta 1 or theta 1 minus theta 2. Don't have to remember anything. Don't have to remember anything. So this is the amplitude or the magnitude of the resultant. I am just talking about the magnitude. Magnitude of the resultant will come out to this formula. This is just the parallelogram law. That's it. I hope you know this, right? So let's do example. Let's do this example. Find the value of addition and subtraction of the two phasors. Okay. So I will prove you with the help of parallelogram law and with simple rectangle format as well that we will verify the results. We will verify the results. So here, if I see, if I do A plus B, it will be 4 angle 30 plus 3 angle 60. So let's just for now find out the magnitude. If I want to just find out the magnitude of A plus B will be what? Magnitude of A plus B, I have told you the formula. Formula is x1 whole square 4 square plus x2 whole square 3 square plus 2x1 x2 4 3 cos of theta. Cos of theta is simply cos of 30. That's it. Cos of 30. So this, right, will be equals to what? This, if I calculate with this method, you will not be able to calculate the angle, but you will be able to calculate the magnitude. So cos 30 is, I think, 1 by root 3 by 2 plus multiplied by 2 into 4 into 3 plus 9 plus 16, 45 whole under root, it will be 6766. Okay, 6.766. So the magnitude should come out to be 6.766. We'll verify that. How do we verify? So here I have the two phases, right? One is 4 angle 30, another one is 3 angle 60. So we can break down the components, correct, in terms of x and y. So the 4 angle 30 will have a x component, so we'll use different pen. We'll have a x component here. It will be what? 4 cos 30. So it will be 4 cos 30. 4 cos 30 is root 3 by 2. So it will be 2 root 3. Correct. And it will have a y component. That will be 4 sin 30. It will be 2. And the second vector, b vector, will also have a x and y component. So x component will be again here. It will be 3 cos 60, which is 3 by 2. And the y component is 3 sin 60, which is root 3 by 2. So somewhat it will be somewhat like this, root 3 root 3 by 2, right? 3 root 3 by 2. Okay, so it will be somewhat more than 2 actually. Okay, so yeah, that is the case over here. So now if I want to do this thing, that here, so now just adding the y and x component. So the y component will be x component will be 2 root 3 plus 3 by 2, and the y component will be j 2 plus 3 root 3 by 2. Correct. So now ultimately, right, I will directly get the rectangular format because I'm just adding two vectors. I hope you know how to do the addition of two vectors. So the x component will come out to be, this is the a plus b. Okay, a plus b. So we represent phases like this. We put a bar or arrow, any one of them. It is just like vectors, correct? So generally we put a bar only. So this will be 2 into root 3 plus 1.5. Okay, so this will be 4.96 plus j 3 into root 3 divided by 2, 2.6 plus 2, 4.598. Okay, these are the two components. 4.96, am I correct? Let me just quickly check. 4 cos 30 will be root 3 by 2. Okay, yeah, this is correct only. So now if I take the square of this 21 plus 4.96 whole square, yeah, it is coming out to be 6 point, like I'm converting it back to my standard polar format. Okay, both are positive, so it will lie in the first quadrant, so I don't have to worry about the angle. So angle will be tan inverse of 4.598 divided by 4.96, tan inverse of that, right? So tan inverse of this is 42.83. I don't care about the angle. But if you see, of course I care about the angle as well. Basically the resultant, right? If you want to get an intuition, where will the resultant lie? Resultant will lie somewhere around here, right? Between 30 degrees and 60. It has to be between 30 and 60 because my extremes are 30 and 60, right? I'm adding these two, the resultant will be somewhere in between. Okay, so yes, it is between 30 and 60. So whatever you have calculated is correct. That is how you can cross verify. So if you see the magnitude that I calculated using this formula and here, both are same. Both are almost identical, 6.766. Okay, so that is, I have proved to you the magnitude is same. Now the homework is the subtraction. Follow the same method for the subtraction, and in the next lecture I will solve for the subtraction. Okay, that is a homework for you, and this is also homework. Represent all these in phasors. Okay, represent, like I have told you how to represent voltage and currents in phasors. Remember, there are negative sign here. Just be careful. Remember, there are negative sign. Okay, how do you represent? And of course, if nothing is mentioned, reference will be your sine omega t. Reference will be sine omega t. That's it. This will be my reference. These are all homework for you. And this side. Now let's understand the operation on sinusoids. So let's say I have, like, this is also sinusoid only, right? Just you tell it is cosinusoid, What is it? It is complementary sine. Basically, after 90 degrees, I get a sine wave, similar to sine wave, right? So if I'm doing the addition operation with two sinusoids, is it applicable? Can I do something like this? That I convert this into phasor. Okay, I convert this into phasor, that is 1 angle 30 degrees, and then I convert this into phasor. What will be? It will 2 angle 60 degrees, and then if I do the addition operation, is it allowed? You will say, okay, I will get some r angle theta. Okay, fine. Now when you once come back to the reformation of the sinusoid, you will write the amplitude will be r, it will be sine. Here what will I write? Will I write omega t or 2 omega t? Because these two have the different frequencies. Both will fight. Omega t will say you should write omega t. 2 omega t will say you should write 2 omega t. There is a fight, right? So of course this is wrong. You cannot do it. You can only add if they have the same frequency. So that is what I have written in this key point, that two sinusoids can be added using their polar or phasor form only if they have the same frequency, as phasor representation is frequency dependent. Phasor representation is frequency dependent. Different frequencies would result in time varying phase relationship, making direct phasor addition invalid. Okay, so because if the frequency is different, right, if there is some different frequency, the information about the frequency gets lost. That is what I have taught at the starting of this lecture. While converting to a phasor, the information about the frequency gets lost. So you cannot simply add two sinusoids if they are of different frequencies. If they have same frequency, yes, you can do this conversion, then add. That is allowed. You can do this conversion, then add. But if they are of different frequency, that is not allowed. You cannot do add. You can only add in polar or phasor form only if they have the same frequency. That is the advantage. Okay. Different frequencies would result in different relation. Now what about the next thing? Can I do this addition? Yes, this is totally valid. So what you have to do, first you have to choose a reference. So my reference is sine omega t. You can choose any other reference. The homework for you is assume reference as cos omega t. That is homework, and please do this. Please do the homework. If you don't do the homework, your concept, right, will be not clear totally. I want you to clear the concept. So I am choosing my reference as sine omega t for now. Okay. So if I choose sine omega t, that means this will be what? This will be 1 angle 30, correct? But this, right, I have to convert into sine. So what is this in sine? It is 2 sine cos can be converted 90 plus theta, correct? So it will be 90 omega t plus 90 plus 60. So this, right, this will be what? This will be 2 sine omega t plus 150. Okay. So, okay, sorry. So now I can write it. Now I can write this in phasor. This phasor will be 2 angle 150. Now I can totally perform the addition, and your addition will be totally correct. So it will be, this one will be 1 angle 30 plus 2 again 150. Now this is the homework for you. Please do the addition r angle theta and verify. What do you have to verify? Using cos omega t as reference, whether the, like, r angle theta will be different whether after this, right, when you try to reconstruct the sine, what will be the reconstruction? It will be r sine, in our case r sine omega t plus theta. If you have chosen cos omega t as reference, your reconstruction will be r cos omega t plus theta. Okay, ultimately you will see both of these will come same because the thetas will be different. Okay, if you solve, then you will understand. I will not solve. I want you to do by yourself. Okay. Next point is, third way to verify is use the formula sine A plus cos B. There is a trigonometric formula, right? Okay, I don't think we will be able to use it, sine A plus cos B, because there are amplitudes are different. Okay, sorry, sine A plus cos B, we will not be able to use it. Okay, yeah, that we will not be able to use. So leave that, just try to verify with this. Okay, that is the homework, and tell me in the comments below, please. I will be waiting for the comments. Please be honest with yourself. Tell me in the comments below, for sine as reference, what is the value of r and theta? For cos as reference, what is the value of r and theta? Okay, I will be waiting at the comments. Next is this question. This also I will be giving you as homework, and in the next lecture, of course, we will solve all the questions. Okay, don't worry about it. So like if v1 and v2 is this, then what is v1 plus v2? Same thing only, whatever I have told you, that thing only we are doing. Now next thing is, can you do the multiplication operation? Is multiplication operation allowed? Is the multiplication operation allowed? So if we say, okay, both are of same frequency and I am multiplying, so let's say I convert this, like this will be what, 2 sine omega t plus 150, and this will be sine omega t plus 30 only. Okay, and if I multiply, so if you want to convert this back into phasor, okay, so this will be 1 angle 30, and this will be 2 angle 150. Okay, this will be 1 angle 30, this will be 2 angle 150. So if that is the case over here, now if I multiply these two phasors, is this allowed? Basically what I will get if I multiply, again it will be 3, no not 3, sorry, 2 angle 180, correct? So if I reconstruct back to my sinusoid, it will be 2 sine omega t plus 180, or it will be minus 2 sine omega t. Now is this correct? No, this is totally wrong. Why is this wrong? Because if you remember, when I multiply sin a plus sin b, right, or sin a cos b or cos a sin b, there is angle addition and difference, right? Angle addition, if you remember this formula, 2 sin a, I will write here, 2 sin a cos b, it has some sort of formula. If you remember, it was from what I remember, it is sin a plus b and minus sin a minus b. Yes, sin a plus b minus sin a minus b. Is that correct? Am I remembering it correct? Sin a cos b, sin a cos b plus cos a sin b. Yes. That I think this is the formula only. So you get two components, two frequency components. So if I add these two frequencies, it will be, one of the components will be 2 omega t plus something, that is in our case it will be what? It will be 2 omega t. Sorry, this is actually not sine. Sorry, this is sine. Sorry, this is like ultimately, right? This is 2 sine a cos b, correct? This is 2 sine a cos b. So it will be sine a plus b. This will be 2 omega t plus 90. One of the frequency, and other frequency will be subtraction, correct? So it will be minus 30. Okay. So one of the component is minus 30. Other component is 2 omega t plus 90. So one of them is constant, that is fine. So it will be sine of minus 30, that is fine. This is a DC term. This will be the DC term, that is frequency independent, frequency 0. Other term has the frequency as 2 omega t. But here what we saw the same frequency. So whenever your frequency, if you perform any operations with the sinusoid and your frequency is changing, that means you will not be able to do the same in the phasor representation. You will not be able to do the same in the phasor representation. That is what I have written in the point, that two sinusoids cannot be multiplied using polar or phasor form, because phasor representation only captures the amplitude and the phase of the signals, not their product behavior. Okay, not their product behavior. Also, one more thing you cannot do. Let's say something like this is written, 1 angle 30 plus 2 cos omega t plus 50. This also is not a valid operation, because 1 angle 30, right? I don't know what is it. Is it just a point? Just a complex number? Or it has a meaning? Or it's a frequency dependent term? I don't know. Okay, I know this is a sinusoid, but what is this? Is this a phasor? Is this a phasor that has a frequency of omega t? Or it can have different frequency as well, right? Can have frequency is also not known, right? So I cannot simply do this operation because the frequency is not known to me. Here what I was doing, yes, I converted this to 1 angle 30, yes, I converted this to 2 angle 150, but internally I know, you also know, that internally the frequency are same, that is understood, it is omega. I know, you know, okay? But here if I just directly write this equation, can you say me what is the frequency here? No, right? the information about the frequency is gone. That is what is written, right? Phasor format, the information about the frequency is gone, so you cannot do this operation. This operation is also not valid. That is like what is written in this points. A complex number and a sinusoid cannot be added using polar or phasor form because phasor representation applies only to time varying signals, while complex numbers is a constant quantity. So this is like a complex number, or it can be phasor quantity as well, but I don't know the frequency. So you cannot add a complex number and a sinusoid because a complex number is just a point in the z plane. This is my real and this is my imaginary. In the z plane, a complex number is just a point. Okay, it is just a point. That's it. X comma y. That's it. A complex number can be multiplied with a sinusoid, assuming the complex number as a constant and the sinusoid as a reference signal in polar phasor. So yes, this is valid. That let's say I have a complex number 1 angle 30 and I multiply this with a sinusoid 2 sine omega t plus 60 or plus 30. So what will this become? This will become 2, or let's say this is 3 only. This will become 6 sine omega t plus 60, given the information. Addition is anyways not possible, but multiplication you can do. But given that you understand that this came, right, this came from a sinusoid of same frequency. This came from a sinusoid of same frequency. That is up to you. That is up to you to figure out that whether this, that you'll understand. Don't worry, you'll understand in the question, you'll understand. And generally these kind of things does not happen. Okay, but if someday they will do it, and trust me, whatever concept I'm teaching you, right, this, right, no one will teach. And I know if you are repeating, if you are a repeater, if you are a dropper, I know this is new to you. That's why we say in PrepFusion that even if you have covered a subject previously, you cover it again, because you will learn a lot of new things that you have not studied previously. And if you are enjoying this lecture, make sure to put a hearts in the comments below, and make sure I'm watching, like tell me that I'm watching here till end, and like just like the video. That is like, that helps us. And put a, like, if you like the lecture, if you enjoy the lecture, make sure you comment down if like what part is the most like enjoying part for you. Okay, that helps us keep going and like give more content on YouTube, right? That motivates us. So yeah, that's just a small gesture from my end. So like from small ask from my end, right? Small demand. So yeah, so what I was saying is, given that you know this is a sinusoid from the same frequency, this object, then you can do the multiplication, simply do the angle addition, those things you can do, given. And division also you can do, given that you know that complex number that came from a sinusoid. It is not a constant complex number. Okay, given that you know this, know the information, then you can do. Basically what happens, right, generally, right, these numbers are the impedance. Impedance, if you know, if someone has studied previously, they will know impedance has a magnitude and angle. Okay, so generally these numbers gets multiplied with sinusoid with impedance. Basically, you know, I, like V is equals to I into Z, right? So Z, we define it in polar, and I is some sinusoid quantity. So if that is the case, then you can do this multiplication, because this Z is derived from the sinusoid only. Okay, Z will be derived from the sinusoid only. So yeah, that is what I wanted to clear in this lecture, and this is the last question that I wanted to give you as homework. And with this we end today's lecture basically. And in the next lecture, like, you can take a screenshot, or all the assignment questions are already shared in our Telegram group. You can join in our Telegram group. All those things have been shared there. Okay, so yeah, that's it basically for this lecture. I hope you have enjoyed. If you do it, make sure to like, share, comment below, like what part you enjoyed the most, and make sure to do the task. Whatever homeworks I have given you, do those. Whatever I have asked you, try to solve those. So thank you for watching, and I will see you in the next lecture. Until then, happy learning.